Hey everyone, welcome back to another episode of Unscripted Coding. Today we are going to look at, again, LeetCode problem number 226, invert binary tree. We did this last week, and I have the code pulled up here. It's not really last week, it's just a couple hours ago for me. But you guys are seeing it the next week, of course. And I made the very rookie classic mistake of not reading the question properly. So let me zoom in. The problem is to invert a tree. And I'm not going to read through this, but the idea is here's a tree, 4, 2, 7, 1, 3, 6, 9. You can see that basically it's a mirror image. So 7 has replaced where 2 is, and 2 has replaced 7. And all of these, this entire level, the third level, has completely flipped. And you can see a simpler example here. Now, where I got stuck on, or rather where I didn't follow instructions, is I got this input and I thought it was a flattened list. You have 4, 2, 7, 1, 3, 6, 9, and we wrote code that was great. It returned this list that went 4, 7, 2, 9, 6, 3, 1. It's longer than necessary, probably, but it's pretty simple. You go down each level, you recognize the trick in that solution is you recognize it's a binary tree. The first level is always going to be one number. The second level is always going to be two numbers, then 4, then 8, then 16. If it was any other type of tree, 4 can have 3 children, 10 children, 100 children nodes. But a binary tree always has 2 children. And so as a result, you always know the first number stays the same. The next 2 numbers have to flip, and then the next 4 numbers have to flip, and so on and so on. Now, I didn't read the question properly because they gave you a structure called a tree node, and they input it here and they output it over here. You need to ingest their class and you need to output in their class as well. I haven't done LeetCode enough. I didn't recognize that. I just assumed here's the input, here's the output. They look like lists to me. So that's a rookie mistake. Always pay attention to the instructions. I know teachers harp on that. People are always saying, when you do an exam, when you're in an interview doing these things, make sure you read the problem. I didn't do that. That was a boneheaded move. But this gives us a chance to do this a second time now that we've thought about it a little bit. So let's look at their structure. It is a tree node. And what strikes me immediately odd is that it is a node rather than a tree. So they're giving you one point in that tree, and I assume it has to be the root. They give you the value, and then they give you the left and right values. And my assumption here is that the left value is going to be another node, and the right value is going to be another node. Unless, of course, they're not. So what I'm going to do is just print that root node and see how it looks like. And obviously, we're going to fail. Yep, we're definitely expected to return in this tree node format. We're not supposed to give a list back. But if you print out the root, you get the value, and then you get the left node, which has a value of 2, which has a left node, which has a value of 1, and that ends. It has a right node that has a right node that has a right node that ends at 9. Okay, so I'm just trying to think through right now. And these images are really helpful. When we were looking at this previous solution, I said we max out at about 6 levels. So 1, 2, 3, 4, 5, 6. It's not a ton of nodes, 100 nodes, but it is still a lot to manage because if you look at this particular tree, um, you want to find out what the far left is. You gotta go left, 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 left. Okay. I have a sneaking suspicion. I think I know what the solution is, but let me just walk you through my train of thought first. We have to go left, 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 left. And the problem and why I was hesitant at first is because it will take a bit of work to build out that level. And I'm still thinking about it in terms of what we did the last time we tackled the problem. We identified here are the 4 numbers in level 3, and then we just flip them all around. And my initial thought is we gotta go down to level 6, gotta identify it all, and that's gonna be problematic because we gotta go left, 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 right, left, 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 right, left, 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 right, right, and build out those numbers. And that is a painful test that will have a bunch of loops to make sure. But what I'm realizing right now is the trick again is that it's a binary tree. We don't have to care how the whole level looks because there's always exactly 2 points. And they even hinted at that with the left and right values. What I mean by that is if you look here, 4 will stay the same, of course, but 2 and 7, all you gotta do is flip 4's left and right nodes. And as soon as you do, 6 and 9 come over here, and then 1 and 3 come over here. And the next bit is you gotta flip those left and right. And essentially, all you have to do to mirror the entire tree is make sure every left node becomes a right node and every right node becomes a left node. You don't have to build out that entire level. You don't need to figure out how all of them look because it is a binary tree. All you have to do is flip the 2 for every single instance that exists in the tree. Okay. We got the theory down. How do we do this? Well, what I want to do first is I'm going to go output equals root just to make a duplicate. And we have these values. So output dot right equals output dot left equals dot right. And of course I can't do that because as soon as you do that, the right value changes. So you have 2 of the same values after this line. I think Python you can do 2 assignments simultaneously with a comma. Right. But if not, we can just have a placeholder value variable. Okay, so I want to print out output, and I want to print root and see how that looks. Let's zoom out a little bit. I don't think that did what I wanted it to do. So I was hoping the left node would switch here. So the left node would say value 2 and the right node would say value 7. Strange. Let me just see what happens if I do this. Yeah, so it does do Oh, oh, okay. I think we're fine with the previous one. Um, because output equals root. I don't even need output, but I like calling my final answer output, but I'm not instantiating a new. I'm not duplicating it. All output is doing is it's pointing to root. So naturally, when I print both of them out, they look the same because they both had the same operations done to them. So that is oh, output dot left. Okay, I think we can do this. Where, okay. So, what we gotta do is carry this down to each level. Uh, ooh, okay, okay. Yeah, I just tend to look at these and then I have a couple different thoughts and I think I know what this one is trying to walk us towards. Okay, so let's walk through my initial thought. I was going to say the current node is the root node, and then the next node is going to be left, and then the right, and then their left, and then their right. And that is going to suck because you don't know how many levels there are. One possible way to do it is just to traverse all the nodes and create a list of all of them. You create a list of all of the nodes, and then I think the problem is slotting them back in. So you can do the reverse, but you gotta go and find where it is in the output and put it back in. So that is a terrible idea. It's probably the most naive way to do it. I don't think there's. I think you can do it, but I think where we're trying to get to here is you are going to want to do a recursion here. So you have output right, output left. And then what you're going to want to do is basically run invert tree on each of these points. So then they will take the left point, do all of the inversion, pass it back up. Okay, all right. It is so clean as an answer that I can't help but think this is exactly what they're looking for as an answer. Okay, let's run it. None type has. Oh, okay. So what it's saying is, I got to the point where it hits the end, and then it's trying to look for this output left. And of course, when you're at the end of the tree, the value is none, so it spits out an error. So I need to do a check here. If output dot right does not equal none, and I don't have to check both left and right. This is a binary tree. It always has two children or none at all. So if they don't have a right child node, there is no left child node. You can probably run the second check anyways, but I'm just being lazy here. All right, let's see how this looks. All right, it is so clean. You might even be able to do this in one line with root because you don't have to do this output thing. That's just something I do out of habit. It is so clean that this has to be the right output. So I'm going to submit this, and then I'll walk you through what the recursion is doing. If none type, oh, if none type, details here. All right, so what this means is I passed output has become none for one of them. And I am going to do a really none. Do a second check here and just submit. See how far we get here. That is very interesting. What is happening? Input is 1, 2. How can input be 1, 2? I think I may have made the wrong assumption here. Because if there is a tree with 1 and 2, that means that binary trees do not absolutely have to have a left and right value. It only has one value, but that makes it not a binary tree. Okay, I am gonna take out these two and submit again to go to the runtime error. Non-type object has no X. All right, let's think this through. You have the root point. Theoretically, they could give you a tree with only one point, the root. You would only do this inversion if I think I should just do both. If output dot right does not equal none, and let's put brackets to make it easier to read, and output dot left does not equal none, then we'll do it. So if, and this is a weird definition, if there's only one node, there's no need to flip it. It doesn't affect anything. And we'll do the check on both sides. So let's run the test case. See how that looks. I don't even understand what it's expecting here. What is one null two? Okay, let's look into the discussions. No. Oh, and you can see most people are doing recursions. Uh, okay, let's take a look. Oh, look at that. If root itself is null, return none. I see. Okay. What was that? All right. If root is none, and they didn't even do a check, because if you pass, okay. So what they did is they didn't need this check because they accept you can pass a none type into it. So if output equals none, then return none. And let's see what happens then. Okay, and then we have the case of 1 and 2. And so you would return the none type. And again, this is not a great question, I think. I don't think we did a poor job of doing our code, but let's submit and see how this looks. There you go. It's done. It's not a great question because the value has never been, it's always between -100 and 100. It says so very clearly. You can't give us a node with none in there and expect us to flip a null and a 2. And so in this case, they gave us a tree of 1 and 2, meaning that 1 is the root and then 2, and we're supposed to assume that there is a none type here. But that's not a binary tree. Not only is it not a binary tree, it's not even in the constraints here. But we did code which would have accepted it. It would have said 1 and then 2. Nice and simple. You don't need to flip if there's nothing here. But of course, because they are saying there can be a node that is none, you have to flip it around. So it needs to say 1 null 2. Were you supposed to figure this out from reading their instructions? I don't think that was very fair, but we did it. It's a cool recursion solution, and so it's a cool recursion solution. You just keep calling the same function over and over. What we did is and I'm just running through this again. You can skip forward a minute or two just to hear me say goodbye. But we have started with the root node. You don't need to do this whole output thing. I do it as a convention myself. You start off with that point. If that point is none, then you come back and give none back. But the idea is you have to reverse all of the rights and lefts. You got to flip them all across the entire tree to get a mirror. And what you do is you replace a right with the left, and you replace a left with the right. What we've done, however, is do this recursion function, the self-invert tree, to each of those points. So if we were to get rid of this and get rid of this, all we've done is replace the 7 and the 2. The 9, let's go with the 2 and the 7 here. The 1 and 3 will just move to the left, and the 6 and the 9 will move to the, right and left. But basically they'll flip places, but they themselves have not flipped. So it would be 6 and 9 here. We haven't flipped the 9 and the 6. What the recursion does is it passes it down to say, okay, we're going to flip these two, but we're going to run the function on the next set so that the 9 and the 6 need to flip. And if there's another level, it's going to run the same function and get the recursion again, another invert tree to say. And for your child nodes, you're going to have to flip them as well. And so the recursion piece is really cool, and I'll admit I probably don't see them as often as really good seasoned programmers do, but it's something that when I learned it the first time, it was such a difficult concept to grasp. And it's such a neat idea to have. It's a really important tool to have. Anyways, enough of me talking. I didn't even really successfully solve this easy problem, which kind of annoys me, really. But is it really our fault that the question is asked and that they've actually given us wrong constraints? Maybe not our fault. Anyways, if you enjoyed this video, if you enjoyed watching me kind of struggle with this easy problem, please do leave a comment below, thumbs up, subscribe, like the video, whatever it may be. If not, do leave a comment as well. It's always nice to hear from you guys if I'm doing well, if I'm doing badly. If it is an absolute joke that I struggled with this question, I'd like to hear it. So, I will see you guys next week for another video in Unscripted Coding. Thanks for watching.